This is the audio for Chapter 12, Lesson 4, Air Masses. It's going to have to do with our weather, our water cycle chapter we're working on. You can read about cyclones and tornadoes on that page. And what are major air masses? All right, when you have a certain type of weather taking place outside, that's because a certain type of air mass is influencing the weather. An air mass is a huge body of air in the lower atmosphere that has similar temperature, humidity, and air pressure at any given height. Scientists classify air masses according to the temperature and humidity. So it's a group of air specific. 4 major types of air masses influence the weather in North America. That's where we live. Maritime tropical, continental tropical, maritime polar, and continental polar. As shown in figure 1, we have this little grid over here. The characteristics of an air mass depend on the temperatures and moisture, so water content, of the region over which the air mass forms. Remember that temperature affects air pressure. Cold, dense air has a higher pressure, so it feels heavier, while warm, less dense air has lower pressure. Tropical or warm air masses form in the tropics and have low pressure. So tropicals have low pressure. Polar or cold air masses form north of 50 degrees north latitude and south of 50 degrees south. So there are polars, our North Pole, South Pole. Polar air masses have high pressure because it's colder and heavier. Whether an air mass is humid or dry depends on whether it forms over water or land. Maritime air masses form over oceans. Water evaporates from the ocean, so the air can become very humid. So of course it sucks up some of that water and it makes it a little bit more wet air. Continental form over the land or the continents. That's pretty easy to remember. Continental air masses have less exposure to large amounts of moisture or water from bodies of water. Therefore, continental air masses are more dry than maritime air masses. So you can connect these wet and dry, dry and warm, or wet and warm, dry and warm, wet and cool. And so you get these kinds. So warm and dry would be like a cactus. Wet and cool would be like our winter season or our colder states. So I'm going to flip to the 436. They're giving us a map of the United States. Take special note because I think this picture is on our final. We have maritime polar, cool, humid air masses form over the icy North Atlantic Ocean. The air masses are often pushed out to sea. So they're here and they get pushed out to sea by westerly winds. Continental polar happens on the continents, but polar because it's closer to the North Pole. Large air masses form over Canada and Alaska and can bring bitterly cold weather, freezing, with low humidity. So less water, but it's very cold. Storms may occur when these air masses move south and collide with the maritime tropical air mass moving north. So I'm going to prelude you here. Cold air and warm air, they can get into fights sometimes. We're going to watch for that on the next page. We talk about cool, humid air masses form over these icy North Pacific Oceans over here. Even in summer, these air masses often cool the west coast. So the cool air comes in, and even in the summer, these states over here are just a little bit cooler than we are on this side, on the east side of the United States. Warm, humid air masses over the Gulf of Mexico and the Atlantic Ocean, they can bring up thunderstorms, heavy rain, snow. We know that there's lots of hurricanes and bad weather down here because of the warm air swooping up. Hot, dry air masses form mostly in summer over dry areas. This is like Mexico's dry, Florida's dry. They can bring hot, dry weather to the southern Great Plains. We learned about water, how important that is for the continents, for vegetation, for plants to grow. Temperature affects it, rain affects it. So if it's hot and it's dry, they may have seasons of drought over here. They have to learn how to plan their crops. Maritime tropic water or warm, humid air masses form over the Pacific Ocean. So we have warm, humid air, so warm, wet air. In summer, they usually bring hot, humid weather. That's what our summers feel like. Summer showers and thunderstorms. In winter, they can bring heavy snow or rain. So because it's coming off the ocean, it's got a lot of water in it, and then it just dumps it right on that land. On page 437, how air masses move. We're going to talk about that. We have a couple pages after that in the chapter. When an air mass moves into an area and interacts with other air masses, it causes the weather to change, sometimes drastically. In the continental United States, air masses are commonly moved by prevailing westerlies and jet streams. So yesterday it was beautiful. Driving home, 80 degrees. Went outside last night for a baseball game. It was like 35 degrees and freezing. I don't know what happened, but the wind came in and it moved some of that weather, and the temperature dropped. And then, like we learned in the chapter before, the temperature dropped, it allowed the clouds to release their water, and then it rained. Prevailing westerlies. The prevailing westerlies, the major wind belts over the continental United States, generally push air masses from west to east. So westerlies is west to east. For example, maritime polar air masses from the Pacific Ocean are blown into the west coast, bringing low clouds and showers. Jet streams. Embedded within the prevailing westerlies are jet streams. Jet streams are bands of high-speed winds at about 10 kilometers above Earth's surface. As jet streams generally blow from west to east, also, air masses are carried along their tracks. So these are winds, these are jet streams, so they're more powerful. Fronts. As high masses of air move across the land and the oceans, they collide with one another, but not easily mix. Think about a bottle of oil and water. The less dense oil, the hot air, floats to the top. Something similar happens when two air masses of different temperature and humidity collide. They do not easily mix. The boundary where the air masses meet becomes a front. So they're standing each other off like hockey. They're face to face. Storms and changeable weather are often developed along fronts like this one. Looks like they're going to have a rumble right here. Oh man. What are the main fronts? So when you leave school in the afternoon, you may find that the weather is different from when the weather you arrived in the morning. That might be because a front has just recently passed through the area. Colliding air masses can form four types of fronts: a cold front, warm front, stationary front, and oculated front. The kind of front that develops depends on the characteristics of the air masses and the direction in which they move. You can think of these wind masses as students. All their characteristics are different, and they get to pick and choose which way they go. It's going to create a different situation either way. I'm not going to read the entire thing of these. I'll just read as much as I can. These next two pages are the end. Nope, there's one more page. So, cold air is dense and tends to sink. Warm air is less dense and tends to rise. When a faster cold air mass runs into a slower warm air mass, the denser cold air slides up under the lighter warm air. The warm air pushes upward along the leading edge of the cold air, and a cold front forms. Warm fronts. Clouds and precipitation also accompany warm fronts. At a warm front, a fast-moving warm air mass overtakes a slower cold air mass. Because the cold air is denser than warm air, the warm air moves over the cold air. If the warmer air is humid, light rain or snow falls along the front. We'll watch some videos to re-establish these connections. Oculated fronts. The most complex weather situation occurs at an oculated front where warm air mass is caught. The denser, cooler air moves up underneath the less dense warm air mass and pushes the warm air upward. The two cooler air masses meet in the middle and may mix. The temperature near the ground becomes cooler. The warm air mass is cut off or oculated. From the ground, and the warm air cools. Its water vapor condenses. The weather may turn cloudy and rain or snow may fall. So that is this picture here. Stationary fronts. Stationary means not moving. So sometimes cold and warm air masses meet, but neither one can move. So it kind of gets stuck there. Stationary. One stays on this side. Do you ever, sometimes on your street, one half of it's raining and the other half is not. That would be a stationary front. Last page. What do weather cyclones and anticlones bring? We will read about those. As air masses collide to form fronts, the boundary between the fronts sometimes becomes distorted. This distortion, so mix-up, can be caused by surface features such as mountains, winds, jet streams. When this happens, the air begins to swirl. The swirling air can cause low pressure center to form. So you could get cyclones. A circled L on a weather map stands for low and indicates an area of relatively low air pressure. So it's softer, lighter air. A swirling center of low air pressure is a cyclone, from a Greek word meaning wheel. As warm air in the center of the cyclone rises, the air pressure decreases. Cooler air blows inward from the nearby areas, or higher air pressure. Winds spiral inward toward the center in the northern hemisphere. The Coriolis effect, which we learned about before, deflects winds to the right. So the cyclone winds spin counterclockwise when viewed from above, like a little tornado. As air rises in a cyclone, the air cools, forming the clouds and precipitation. Cyclones and decreasing air pressure are associated with clouds, wind, and precipitation. So anticlones, as the name suggests, an anticlone is the opposite of a cyclone. So a cyclone goes this way like a clock. This one's going the opposite way. It's a high pressure center of air. It's shown by an H on a weather map. Winds spiral outward from the center, moving towards areas of lower pressure. Because of the Coriolis effect, winds in the cyclone spin clockwise instead of in the northern hemisphere. Air moves out from the center. Cool air moves downward from higher in the troposphere. The cool air warms up, so it's relatively humid, so wet air. The descending air in an anticlone generally causes dry, clear weather. So if it's swirling up, low pressure. If it's swirling down, it's more dry weather.